Hey everybody, I wanted to finish up the series by covering the last and final topic. I did this video already once, and I wasn't very happy with it. I had to bring in an outside source, which to me just makes me sound like I don't know what I'm talking about. So what I'm going to do is I'm going to run through Nat, and there's actually 4 different types of Nat that I want to cover, and it should go by pretty quick. I've already got some everything fired up. All the routes are routing. Things are looking good. I've already got everything situated the way that they need to be situated. So what I'm going to do is I'm going to get NAT set up, and I know I have my IP address ranges already situated. So R1 will be doing all of it. That'll be our NAT router, to where it'll be taking anything that comes inbound to it. It'll be doing the natting that needs to be done. So with that being said, the most common NAT that you guys will need to worry about is what they call a NAT overload, which means you're going to take a range of IP addresses from your internal network, and you're going to send them out a single interface out towards the internet. So anything that comes in from here will get shipped out this way. Now, the only caveat with NAT overload is the overload statement. When you consider the term NAT, it's network address translation. It's what it actually stands for. And what that means is this: when you take one IP address and you have another IP address that are side by side each other, so you take this range right here and this range right here, they're the same subnet, well, the same major network, 172.20. And basically, what you end up doing is you say, okay, anything from this network, I want to translate to this network. So inside it looks like this, but outside it looks like that, is basically what you're doing. That's called static one-to-one NAT. Well, that's not what we're going to do here. We are going to do what they call NAT overload. So fast00 is going to be our internet router. And as you can see, I can ping my internet gateway, so that should work. So what I'm going to do here is I'm going to show you how the access list works, and then show you how we're going to go at it beyond that. I'm going to set up static NAT, and then I'm going to set up NAT overload, so that you can get your entire local subnet. You know, you may have multiple subnets that you want to translate, but you're going to translate anything that you have on your network that needs to get out to the internet. And that's really simple. We're going to go to global config mode and type in IP access list, and we're going to type, it's going to be a standard access list, and we're going to hit, I'm going to name it, it's going to be NAT. I'm going to name that NAT1, okay, because this will be, or NAT inside. Okay, NAT inside. So it'll be our internal network. Okay, we hit enter. We're going to permit the 172.20.0.0, and we're going to be, our wildcard mask is 0.0.0.255. So only anything in this range is going to matter. So that last octet right here, this guy, that's the only one that's going to matter. Because it's 0.0.0 means I pay attention to these guys, so it must match 172.20.0. And then the last octet, I don't care. It can be whatever. So that's what we're going to do. Hit enter. And then what we're going to do is we're going to hit exit. And we're going to type in do show access list. And there, we have an access list put in there. So what we're going to do now is we're going to type in this. And I will type it in, and I will translate it in English for you. I'm going to type in IP NAT. Inside source list NAT, NATINSIDE, and you want to send it out an interface fast 0/0, and I want to overload that. Okay, what does that mean? That means this, and I kept it the way I did it for a reason. That means I would want to NAT from the inside of my network using the source access list NAT inside, and I want to take those addresses inside of NAT inside access list and translate them out interface fast 0/0, which is this interface right here, and I want to overload that. So if we end and do show access list. There. Oh, how about show IP Nat Translations? Nothing's going on right now because nothing's trying to get out to the internet. So I'm going to go to, I've already got R4, R6 pulled up. Well, actually, I didn't load that one through yet because I have to still make a translation for that. So what I will do is I will do this. I'll go config T. This is where when you're actually doing this, you want to make sure you grab, write out on paper before you do it. I'm going to type in IP access list Nat inside. Oh, I'm sorry. We're going to say standard. Type in Nat inside. Type in permit 10.1.1.0 0.0.0.255. Okay, so that allows me to do that as well. So what that'll do is it'll grab any network that it matches and show access list. There. We have the 172.20.00 wildcard bits and the 10.1.1.1.0 wildcard bits. It's only going to match the last octet. So what ends up happening at that point is anything that matches this, it'll get shipped out. So if you do a show IP Nat Translations, nothing's happening right now. And why is that? Well, it's because nothing's going out to be translated. So this was me making sure that my routing was going to work. So what we do is we telnet to 192.168.1.1 out port 80 and hit enter. It's open. Let's hit up arrow again. And there, it's translating. So what that tells me is it's translating 192.168.1.103 on port 63,206 out 10.1.1.1.1, which is the fast Ethernet 1/0 IP interface with that IP address on it, out 63.206, and it's being translated to 192.168.1.1 on port 80, and that's the outside local and outside global. Well, because of the fact that this is still an internal private IP address, it's not going to go anywhere. So my home router is the one that's that IP address of that, so that's all that matters. So we have that set up. Now that's Nat Overload. Now, what happens if you happen to you work for a company or you consult and you're called in and they say, hey, we have a couple of some web servers and we have some other stuff that we want our outside users to be able to access, download information from, so we want an FTP. I'm like, sure, that's not a, or I'm sorry, I'll do that in a minute. But we have a web server that we want that we want to be able to get to. So how would we set that up? Well, that's really simple. Well, what we end up doing is we do a static one-to-one. So you would say we have a web server that we want to get to. So what we do is we find out what IP address that's going to be. So what we do is we go config T, type in IP NAT question mark. What type of NAT do we want to have? Well, we want to have a inside. I had to think about that for a second. And we want a question mark. What do we want to have? Do we want it to be a destination or source? The source address will be this. Source, and it's going to be a static local to global. Now let me do this. Inside NAT outside question mark source question mark. See how the local to global, depending on how you put it in, changes from global to local? Okay, well, it doesn't matter which way you do it because it's going to be a static one-to-one. It doesn't matter what's going to happen. That's all that matters. So we're going to do inside. Inside source is going to be a static NAT mapping, question mark. What's the inside local IP address? What do we want to translate? Well, we're going to translate 10.1.1.2 out, and what is the global IP address? It's 192.168.1.1. Or, I'm sorry. So what we end up doing at that point is 1.1. Yeah, we'll do a 1.1 and question mark. And that's all we need to do with that one because it's a static one-to-one mapping. We hit enter. So now, if we do end, and we do show IP Nat Translations, that one will always be in there. Okay? So, basically what this is saying is this. Right now, nothing's being translated because it's my internal network. So, what we end up doing is we say, this is my inside local IP address. This is what I have actually on my web server configured on the network the network interface. This is my outside IP address to the internet. That's what that says. Now, this and this will be the same as this and this in most cases. It depends on what your public IP address is and other things like that. So that's going to be the same. Now, for the remainder of the connectivity, the next one I'll do is I will show you how to set up static NAT mappings to based on port assignment. And what I mean by port assignment is you can take one public IP address and overload it to many internal IP addresses. Okay, since we now have both Nat Overload and Nat boy, I just can't remember what I put in there. A static NAT, 1-to-1. Now we have the option of doing this thing they call static port translation. So what does that mean? That means we can set up static addresses, one static address and multiple port numbers. Now the only caveat to this is if you have one public IP address and it's just one public IP address. If you have one public IP address and you have multiple servers or multiple internal IP addresses, they are going to be the same type of protocol, meaning TCP port 80, TCP port 21, TCP port whatever else, UDP 63 if you're doing DNS, or I'm sorry, 53 if you're doing DNS. Any of these ports that you need to use, the more ports that you're going to utilize, the more public IP addresses you're going to need. Now, there is a caveat to that where you could use load balancing and go along that, but in the matter of the CCNA, we're not going to worry about that. So we're going to set up static port translation. So static port translation is pretty much like this. On R1, what we're going to do is we're going to go to global config. We're going to type in IP. Oh, I'm sorry. We had to get off that. Couldn't see what I was typing. We're going to have to set up a pool of addresses, both externally and internally. So what we're going to do is we're going to type in IP NAT pool word. We're going to type in NAT outside. Enter. It's an incomplete command. Okay, no problem. The static start IP address is what? We're going to type in... Oh, my bad. Wrong one. We're going to type in IP NAT inside. We'll do that other one here in a second. We're going to type in IP NAT inside source static and type in the IP address 172.20.0.138. And you know what? I know what I forgot to do. TCP. And we're going to question mark and inside local IP address. Because we're going to match based on, actually, let's do this. We have options. We want to match based on UDP, based on TCP, or do we want to do some sort of IPsec VPN tunnel? So we're going to do this. We're going to do TCP. And we're typing 172.20.0.138, and we're typing question mark local TCP IP number, or what's the port number that we're going to use? We're going to make it a web address, so 80 question mark to what's the inside global IP address? We're going to type in 192.168.1.1 question mark. What's the outside IP address? What's the global port that it's going to match to? And that's 80 question mark. And that is all we need to deal with. All this other stuff is way beyond anything we're going to deal with in the CCNA level. So enter. Oh, okay, no problem. So what we're going to do is we're going to control U. We're going to do show run include let's see, IP NAT. And we're going to take this entry as soon as it comes back right here, because it's already mapped. It's already a static NAT mapping. Take this guy. We're gonna type in no and hit right click. that takes that entry out. Then what we're going to do is we're going to hit the up arrow twice. There. Now it's taking it. We do show IP Nat Translations, and there it is. So now we're mapping from the outside of our network to the inside. So the inside IP address to our web server is 172.20.138 on port 80 is mapped to 192.168.1.1 on port 80, and it's a TCP is the protocol. That means that anybody on the outside coming in will hit the 192.168.1.1 IP address and be mapped over port 80 to our 172.20.138. So if we have a web server set up for that port number and that IP address, it'll map it to that. So you could take that 192.168 IP address, let's say that's your public IP, and you can map that to several port IDs with the same public IP, and then map it to many internal IP addresses with different port numbers. So what I could do here is do this. Instead of doing 80, we're going to do 25. Okay? Same thing here. 25. Does the same thing. Do show IP Nat Translations. Now we have two. We have one that goes for internet web or internet for www for HTTP. We have one that goes for email. We can do it again, and we could do the port number could be, let's see, we can do 443 because it could be secure web. And we'll do another one here, 443 as well. So that means when they come into the website, they could log into their account and use 443. Same thing, show IP Nat Translations, and there we have the mapping. So they're all going to the same IP address internally and externally, but different port mappings. So this way here you can use every public IP address to the max, rather than having to have separate public IP addresses for each one. Now, if you have multiple cases where you have the same port number and the same multiple internal IP addresses, you have to have multiple public IPs in order for that to work. In most cases, you could do a situation where you could have one public IP and you could branch it off to where if it comes in, you could do a dynamic NAT with overload to where you can have it go to a separate public IP address, or I'm sorry, a separate private IP address for a web server that's got the same information on it, or you could load balance it across multiple internal web servers to where you could have 50 web servers set up on a server farm and have a load balancer sitting in front of that, to where as traffic comes inbound to it, it knows how to replicate information out and pull it in. That's way beyond the scope of what the CCNA covers. We do it a lot at my job, so it comes into, you end up having a content switch. So the content switch takes the information inbound from the customer. Customer goes in and says, hey, I want to be able to access my bank account. It's routed to where it needs to go. There's a front-end processor, what we call a FEP. The FEP takes that information and says, okay, you're going to go to your bank account's website. All this stuff is, the mainframes are housed internally in our network, so they're behind all our security. So when you take that and place the NAT behind it, it makes it a lot more scalable. Okay, now that I've covered both NAT overload, to where you can take one public IP address and overload it so that multiple internal IP addresses can get out to the same public IP address. We've covered static one-to-one, which actually I just took that out so you guys could see dynamic or multiple port address translations. So we're using NAT, and I've also shown you PAT, so we're doing it based on the port of the same public IP. So now what we're going to do, and then we've done static one-to-one, we've done NAT overload, and we've done static PAT. So the last and final one is what they call NAT, or dynamic NAT. So what is that? What do you mean by dynamic NAT? Well, it's actually really, really simple. It's really easy to figure out. This is what we're going to do. We, as the administrator, are going to come into the router, and we're going to do show access list dash L. So right now we have 172.20.0.0, and currently this guy had one hit because this guy over here hit it, as you can see right there. The 10-1 hit it. That's why we have one match. So what we're going to do now is we're going to set up dynamic NAT with overload. So what we're going to do is we're going to go global config, which is where we're at. We're typing IP NAT pool, and we're going to type in NAT outside question mark. We're going to link the start. I just had dinner. Excuse me. the start IP is going to be, we're going to make it something unique. We're going to type in 192.168.2.1 through actually I should say question mark, end IP address 192.168.2.2. Okay, so we have two public IP addresses in this case. Question mark. What is the net mask or prefix length? What do we want? The net mask is basically the same thing as a subnet. So we're going to type in net mask and type in 255.255.255. We're going to go. What should we make this? Make it a 240, just for the sake of argument. So there. So what does that say? That says, and as you can see, it's a little long, but Control A says IP NAT. I want a NAT, the pool NAT outside to the public IP address is 192.168.2.1 and 2.2. Net mask 255.255.255.240, and that's all we have to do right now. So what we're going to do is we've already got NAT inside. So how do I know NAT inside? Well, we have NAT inside right here. Okay, we have NAT inside, and that covers the 172 and 110 networks. So now what we're going to do, we're going to hit Control U. We're going to type in IP NAT question mark. Oh, IP NAT question mark. I want to go from a pool of addresses. One more L or O question mark. What's the what do we want a NAT? We want a NAT inside question mark. So start I. Oh, I'm sorry. My bad. I was in the process of trying to configure it again. IP NAT inside. You want a NAT. The source is going to be list NAT inside question mark to another pool. So you want a NAT the 172.20 and the 10.1 networks and that are listed in NAT inside's access list. You want to map that to another pool question mark, and what's the name of that one? That's going to be NAT outside. Okay, so you can type it right. Outside question mark, and we want to overload this. Okay, so what does that do for us now? Enter. So now we do show IP, actually end, show IP Nat Translations. Currently, the only ones that are going to show up are the static mappings that we've done based on the port. So now I'm going to come over here, do the same thing I did just a minute ago, except for I'm going to do this. Let's do 2.1. So now it's trying to open that up, and we're going to hit show IP Nat Translations. And there we have it. Now 192.168.2.2 on port 3775, 10.1.1.1, 37.775 to 192.168.2.1 and 2.1 on port 80. So this is the internal IP address. This is the public IP address that it's being natted to. And then this is how it's getting out to the internet. So that right there shows you, going based on that, NAT overload, bringing our internal network to the outside world. Static one-to-one, which is how you configure one public IP address to one private IP address for web services or whatever else you decide to do. And then we have static port translation, so we can map one public IP and one internal IP address based on several port numbers, as you can see there. And then we have the final one, which is dynamic NAT, which is where we take one pool, map it to another pool, and we overload that pool. So we take, if one pool gets overloaded to where there's nothing left for it to do, we can turn around and we can NAT it to another IP address. So those are all the flavors of NAT. To be honest with you, it took me a long time to get that, because it was so many little, you get one down. The easiest one obviously was NAT overload, because it's just, simple access list, and that's all you got to do. The more difficult ones were the ones where you get based on port number, where you're taking two different NAT pools and you're able to overload them. So we have to do a show access list. we still only have one access list. We have the NAT inside, which is covering all of our public or all of our private IP addresses, and then as you can see, I have 2 matches. And as you can see up here, the 192.168 IP address is what was natted. And if you notice right here, NAT outside 192.168.2.1 and 2.2. So that's how we end up getting it to flip over from one side to the other. That right there is going to be your saving grace if you have multiple public IP addresses and multiple private IP addresses, and your boss says, hey, we're going to add more web servers, we're going to add more FTP servers, we want you to be able to start setting this up. So what you can do, you can set up TCP based and UDP based. So you can not only do it, where am I at here? You can set it up based on port number, like I did here, and set up 443. You can set up 25 for SMTP for email, and for secure web surfing. You can set all that up on top of what else the other things you have running. So your router could be doing multiple things at the same time. Now understand this: the more things you have your router doing, the more work it's going to have to do. Obviously, it's going to be more resource intensive. So one thing I recommend doing is this. I don't know if anybody's ever seen this before, but show IP Ceph. What is Ceph? Ceph is a great thing. I love Ceph. I recommend it to anybody that I can ever talk to. Ceph is a layer 2 feature, and the only reason I'm touching on this is because of the fact that everything we've talked about is going to have to know a MAC address, which is layer 2, and an IP address, which is layer 3. And that's exactly what Ceph does. It maps your layer 3 to your layer 2, and it's like instantly fast. It's much faster than process switching, which uses the processor or the router to process each packet and determine where it's going to go. And then you got fast switching, which is a little bit faster because it caches the information. And then you have Ceph switching. Ceph switching kind of draws from the other two, but once the adjacency table is written and there is the FIB, the forwarding information base is there, and the RIB, the routing information base is put in. The FIB and the RIB, once those are put into place, Ceph can run. Now, some people say Ceph is too far advanced with the CCNA. I say you can never get too early with Ceph. Because Ceph is going to be one of those things where if you understand what it does, you can figure out exactly what's going on and where things are going. So let me explain quickly what Ceph does. Ceph, in a nutshell, is a layer 2 function, which I've already mentioned. What it does is this. It maps, let's see here, 172.20.139/32. Okay, it knows how to get there, right? And it knows that 172.20.139, to get there, it's going to have to go out 0001 subinterface 102. What does that mean? Well, as Ceph works, it builds up an adjacency table. It also knows all of the IP address to MAC address mappings, so show ARP. And you're like, well, what does that mean? It means this. Currently, right now, we have plugged in 10.1.1, we have 10.1.1.2 and 192.168 are our IP addresses here on the router. 192.168.103 should be show IP interface brief, should be the IP address of our so this guy 103, this guy right here are connected. You see that 1.1, that's technically that's our which we call it 10.1.1.1 is or 192.168. That's our way to get to our static route pointing out towards the internet. As you can see, we've learned this one via DHCP, which is fine. And then we have this network virtual interface. And if you notice, it's the same IP address as this guy. Well, how does that work? Well, an NVIO, network virtual interface, it only comes into play when NAT comes into play. If you've got a NAT router that you want to configure, and you want it to be able to NAT, the NVIO is going to come in, and it's going to be like a loopback, but only there when NAT is running. So you can change the IP address of this guy, but there's really no need to, because that's the it's going to leave out this interface, so it just takes that interface. So if you do a show interface null 0, you can see that right now hardware is unknown because it's a logical interface. It was created when I turned Nat on and got that up and running. So currently NVIO right now is not doing anything. It's just kind of hanging out here on the router. But like I said, with Ceph, as something comes in or is going to go out, if it's going to go out to say the 10.1.1.1 IP address, which is R6's IP address, it knows how to. The next hop is 10.1.1.1, and it's going to go out fast Ethernet 0/1. This is prettied up. Basically, what it says underneath the hood is it says this is the MAC address of the next. Or I'm sorry, this is how it's going to get out there. This is where it's got to go. It already knows the MAC address of its next hop router. So it does a MAC address that says, okay, 10.1.1.1's MAC address is whatever. So that's how it knows how to get out to where it's got to go. In order to run a lot of different features with Cisco, Ceph has got to be running. In order for you to run MPLS, it's got to be running. There's some BGP stuff that you got to have where it's got to be running. Just understand this. The less processing that the CPU has to do on the router, the faster the router is going to be. So if your backplane can accept say several hundred megabit per second throughput from port to port in its switching, and you're switching it via hardware, it's going to go a lot faster than having to have the software feature, the iOS, look at it and go, okay, well, what do I got to do with this? Every time this processor's got to stop, look at the incoming data, look at the incoming MAC or Ethernet packet, the frame, and say, okay, where are you going? It strips off the source and destination information for the MAC address, flips that over, so the new source is going to be the IP address of the next hop router. It's going to be the MAC address. The source is going to be the outgoing interface. So it's coming in, source and destination MAC address changes. The new source is going to be the next hop router's MAC address of that interface. The source is going to be, the destination is going to be the next hop router's IP address to MAC mapping, the ARP, and the next hop or the outgoing interface is going to be the source. So once it comes in, it goes right back out. Ceph takes care of that for us. As you can see, it says receive attached. So 168/30. That is the point-to-point that I have here, and then 169 is attached because that's attached to my router, and then 170 is received. So the best way to look at it is, and then this is the range, 68, 69, 70, 71. This is the broadcast. So when you're shipping information in and out, Ceph looks at that and knows what to do with it. It goes a lot faster than anything that the processor can handle. So it's going to be a lot faster than fast switching. It's going to be a lot faster than process switching. So if you do a show proc CPU sorted, it's going to show you the top ones up front. And currently, right now, we're using 30%, but it's actually my computer CPU that's actually doing this. And you see IP ARP retry age. That's the highest usage in the last couple of seconds, and it's the average high for the last minute. Well, actually, it's PPP, because I'm running PPP here. Now, as you see this IP input, that's process switching. It doesn't turn process switching and fast switching off. It just takes the information and it does other things with it. So that's the best way I can put it, because I'm not exactly sure the best way to leave it with that, but that's how that goes. So I'm going to go ahead and I'm going to write mem to this, because that's pretty much everything we need to worry about. I'm going to stop this video, I'm going to start up another one, and I'm going to try to get PPP authentication to work so you guys can see how that works. I hope this has been informative for you, and I would like to thank you for viewing.